Okay, 2006 question number 3. This particular problem, in my opinion, is one of the most poorly worded questions they have and very confusing. So I'll do my best. If the true depth at a certain point is 2 feet, what's the probability the depth measurement will be negative? Well, there's multiple ways to solve this problem, and that's part of the confusion. But the measurement is assumed to be normally distributed with a mean of 0 and standard deviation of 1.5. So most of my students want to start with that, and so that's the way I'm going to approach this. So most of my students go, all right, the mean is 0. They tell me it's normally distributed, and I have a standard deviation of 1.5. Okay? Well, if that's the case, well, I guess I should say that since it's normal, we know we're going to be plugging into z equals x minus mu over sigma. Now, they tell me I have a depth of 2 feet, and it needs to be negative. Well, to be negative, I have to go this way, which means below 0. So this means I have to be 2 feet below 0. And so they're looking for this area right here. So if I do that, this becomes -2 minus 0 over 1.5. And I can do a second VARS normal CDF. My lower bound's negative infinity. My upper bound in this case would be -2, looking at the shading. Mean is 0, standard deviation 1.5, and I get 0.0912. So that probability that z is less than or equal to this equals 0.0912. Personally, I preferred to look at it this way. I know it's normal. I know what the standard deviation is. I centered it at 2, and then anything below 0 would have been negative. The standard deviation is still 1.5. If I had done that, I'd get the probability that z is less than or equal to 0 minus 2 over 1.5. And when I put that into the calculator, my lower bound's the same. My upper bound has changed to 0. My standard deviation is 2. My mean is 2, and my standard deviation is still 1.5. Once again, I'm going to get the same value. So either one of those two methods, whichever one makes more sense to you, is the one you should use. Now, it says, suppose 3 independent depth measurements are taken at the point where the true depth is 2 feet. What's the probability that at least one of these will be negative? Here we have a fixed number of trials at 3. We cannot use a normal approximation because we're not going to satisfy NP and NQ, which would both have to be greater than or equal to 10. So we know that's not going to be the case. So we're going to be stuck with using the binomial with a fixed number of trials. So they want the probability that at least one of the 3 measurements would be greater than 0. So we can have these possibilities: 0, 1, 2, 3. This is what they're looking for. So 1 minus the binom, and since it's a singular value of 0, we can do a 1 minus a binomial PDF of 0, where x equals 0. This will give you no credit. So what you need to show in your work would be something like this. And you have 2 options again here. You can do 3, choose 1. Our probability of that happening is 0.0912 from up above to the first. 1 minus 0.0912 squared. And it's going to be plus ... plus 3, choose 3, then 0.0912 cubed, and then 1 minus 0.0912 to the 0. Now it would sum all the PDFs. The other way would be 1 minus 3, choose 0, 0.0912 to the 0, 1 minus 0.0912 cubed. And if I'm going to go ahead and use this method right here when I plug it in the calculator, so 1 minus second vars binomial PDF 3.0912, and my x value happens to be 0 this time. And there's a 0.2494 chance of that happening. So the probability that x is greater than or equal to 1 equals 0.2494. The last one says, what's the probability that the mean of the 3 independent depth measurements will be negative? So now we're talking about the mean, or the average, okay? Well, because this is normally distributed, I can go ahead and use z equals x minus mu sigma divided by the square root of n, make sure this is an x bar, and they want to know the probability that it'll be negative. I'm going to go ahead and use, I can use either one of these methods that I used in part A, and I guess I will do both of them. So the first one, I had the diagram drawn like this. We had it centered at 0, and we said -2. So this is what I'm looking for. Well, when I plug into this, I want the probability that z is less than or equal to -2 minus 0 over 1.5, which was the standard deviation, divided by the square root of 3. So second vars, normal CDF, my lower bound's -infinity, my upper bound was -2 with this particular, and then my standard deviation is 1.5 divided by the square root of 3, which I just raised to the half power. But when I do that, I find out it's 0.0104. If I use the other method, or the other diagram, where we're centered at -2, we're centered at a +2, but 0 represents when we go negative. It's still going to be set up the same way, but it's the probability that z is less than or equal to 0 minus 2 over 1.5 divided by the square root of 3. When I plug that into the calculator, again, it's second vars, normal CDF. Lower bound still the same because it's negative. Upper bound, in this case, is a +2. Is 0 based on my shading. Really important to have that graph so you don't make those type of input errors. Standard deviation is still 1.5 divided by the square root of 3.5. And once again, I would get the exact same answer. So either one of those two methods is acceptable.